Welcome to another edition of Final Countdown. This is week 10, day 2. Week 10, day 2. Let's get into work. The far point of a near sight at I is 50 centimeters. Far point of a near sight at I is 50 centimeters. Right. In front of the eye, to see objects clearly at infinity, the lens mode is 2 centimeters in front of the eye. What should be the lens? So, to view objects at infinity, so there is a lens, whatever the lens you are wearing, short-sighted eye, two centimeters in front of the eye, light rays coming from infinity will diverge. If you extend the rays, the image should form. Image from the lens should be object for the eye. That is at a distance 50 centimeter from the eye. Then light rays seems to come from the far point. It will converge on the retina. So if this is 50 centimeter, this is 2 centimeter, this is going to be 48 centimeters. So if you write this down, 1OV minus 1OU equal 1OF. Object is at infinity, image is formed at 48, focal length of the lens. Focal length of the lens is plus 48 centimeters. Diverging lens with focal length 48. Diverging length with focal length 48. There you go. Right. A point object is placed between two parallel plane mirrors. Which of the following diagram shows the location of the second image formed by each mirror? Second image formed by each mirror. Object here, image here. Object here, image here. This becomes the object for that. Object here, image there. Object here, image somewhere here. So you can see first one is wrong. Object here, image. Object here, image. This image will act as the object for that. I1 dash. This image will act as the object for that. I2 dash. Second one was wrong. Here, object distance equal image distance. Object distance equal image distance. This will act as the object there. Object equals image. I1 dash. Object equals image. I2 dash. This looks correct. So the image for the second location correct. Right. A planet mass subtends an angle 8 10 to the power minus 5 radian at an unaided eye. So alpha is given 8 10 to the power minus 5 radian. There you go. When mass is viewed using an astronomical telescope in normal adjustment, the angle subtended on the eye is 2.4 10 to the power minus 3 radian. If the focal length of the eyepiece is 0.03, focal length of the objective is, look at this carefully, Beta divided by alpha is F naught over Fe. Beta is 2.4 10 to the power minus 3. Alpha is 8 10 to the power minus 5. Focal length of objective, we don't know. Focal length of IP is 0.03. Simplify this. 0.3 10 to the power 2. F naught 0.03. Simplify this. F naught 30 multiplied by 0.03. 0.9 meters. Correct answer is answer number 4. Correct answer is answer number 4. Okay. Correct answer number 4. Right. A set of identical kettles are fitted with heating coils of different wattages. If the kettles are used to boil the same amount of water, mass, which of the following curves best represents the variation of time that is required to raise the temperature of water to its boiling point? So heat given, power into time, that is mass of water, specific heat capacity of water, change in temperature is 100 minus theta, let's say room temperature. Right. So time with wattage, get this carefully. Now mass is same, specific heat capacity is same, change is also same. So when the power increases, the time taken will what? Reduce. Power increases, time taken will reduce. Which means the most suitable graph, inversely proportional, most suitable graph will be graph number 5. Power increases, time will reduce. Right. Question number 5. Consider a rubber balloon filled with air. Inside and outside pressures of the balloon are P1 and P2 respectively. And the temperature outside are the same. Which of the following is true? So pressures are equal inside outside. P1 equal P2 as the temperature on either side remains the same. P1 is larger than P2 due to high mean speed of air molecules inside the balloon. P1 larger than P2 due to high mean kinetic energy of the air molecules inside the balloon. P1 larger than P2. Now remember, kinetic energy depends on temperature. Yeah. Kinetic energy depends on temperature. Temperature same means kinetic energy same. P1 larger than P2 due to high rate of collisions of air molecules inside with the walls of the balloon. Now that may be correct. That may be correct. P1 larger due to low mean kinetic energy. Remember this. Temperature constant, mean kinetic energy same. So this is wrong. This is wrong. P1 larger than P2 due to high mean speeds of air molecules. Remember, the speed is directly proportional to square root of temperature. Temperature same, so this is wrong. P1 equal P2 due to same temperature on the other side. Now remember this. Even though the temperatures are same, here the number of molecules is larger compared to that. So one is also wrong. So most suitable answer is going to be answer number 4. Answer number 4. P1 is larger than P2 because there is large number of collisions taking place. Large number of collisions taking place. Okay. Right. Look at this. Figure shows a cross-section view of 3 hollow cylinders A, B, C made from different materials: lead, brass and steel. Lead, brass and steel. They barely fit one another. If the cylinders are heated, the cylinder C falls off, while cylinder A becomes tight. Cylinder C is falling off because expansion is large. Larger expansion means here it's lead. Large expansion means here it's lead. There. So C is going to be lead. Then A is getting tightly fit. A is going to be steel. Sorry, A is going to be brass, and B is going to be steel. So correct answer number 3. Right now. So here these falling off means large expansion. Large expansion means it's going to be lead. And A is going to be tightly fit. A is expanding more. A is expanding more means brass. So correct answer is answer number 3. Correct answer is answer number 3. Okay. Right. A point charge Q0 moves under the influence of electric field created by another stationary point charge simple Q. Right. So this will create an electric field. Let's say the kinetic energy of Q0 when it moves from A to B. Look at this very carefully. Find the potential at A, find the potential at B. So Q divided by 4 pi epsilon naught R1. Here Q divided by 4 pi epsilon naught R2. So looking at this, what can you say? Potential at A is going to be greater than potential at B. We don't need to do work, field will do work. Right. So work done to move from A to B is potential at B multiplied by the charge minus potential at A multiplied by the charge. Q squared or Q naught. Q times Q naught divided by 4 pi epsilon naught R2 minus Q times Q naught divided by 4 pi epsilon naught R1. Q naught over 4 pi epsilon naught 1 over R2 minus 1 over R1. So you get a negative answer. Negative answer which is correct. Here. Negative answer which is correct. So work is done. Work is done by the field. Work is done by the field. So here negative answer. Negative work done. So work done from A to B is, put the negative this side, Q naught divided by 4 pi epsilon naught 1 over R1 minus 1 over R2, which means your answer is going to be answer number 2. Answer number 2. So find the potential here, find the potential there. Potential multiplied by charge will give you energy. Difference in energy is final minus initial. It's going to be a negative value. Why? Field is doing work. Here if I put a plus Q naught, positive, repulsive. So field is doing work. So work should be minus. Put it here, simplify it, you get the answer. Okay. Right. Question number 8. Diagram below shows situations where two charges plus Q minus Q move with uniform velocity and separately enters 5 regions having uniform electric field as shown. Vectors E and B are always perpendicular to each other and vector V can be either perpendicular or parallel to E. Which of the following configurations may provide a possibility of charges to move across a region without changing direction? So without changing direction means guaranteed very simple. Electric field and magnetic field should be perpendicular to each other. Now if I look at this, field is in that direction. So positive charge will be attracted towards the negative plate. So here electric force is in that direction. Here electric force is in that direction. Here electric force will be in the opposite direction. Right. Here negative charge, electric force will be in the opposite direction. Negative charge, electric force will be in the opposite direction. There you go. So the electric force is there. What can you say about the magnetic force? Field, motion, force upward. Left hand rule. Field, motion upwards. So magnetic field will also be in the upward direction. Magnetic force was in the upward direction. Right. Here you go. Field charges are coming this way, force upwards. Magnetic force upwards. Here. Field negative charge traveling in that direction, current opposite, force inwards. Magnetic force here. Here. Field negative charges means their current is opposite. Magnetic force downwards. Here. Field negative charges means force downwards. Magnetic force downwards. Electric force upwards. Most suitable will be answer number 5. Most suitable will be answer number 5. Forces are in opposite direction. Question number 9. A spherical liquid drop has electric capacitance C1 and another spherical drop made from the same liquid has capacitance C2. If these two drops are coalesced together to form one drop, what will be the capacitance? C1 is equal to 4 pi epsilon naught R1. C2 is equal to 4 pi epsilon naught R2. Careful. Spherical droplets are joining means 4 over 3 pi R1 cube, 4 over 3 pi R2 cube. That is equal to 4 over 3 pi simple R cube. R1 cube, R2 cube, R cube. There you go. Then they are asking you the capacitance when they coalesce. C equals 4 pi epsilon naught R. Here C is equal to 4 pi epsilon naught. R means R1 cube, R2 cube, whole thing cube root. Whole thing cube root. So here if you build a relationship, right? So if I send this in, four pi epsilon naught cube R1 cube, 4 pi epsilon naught cube R2 cube, 4 pi epsilon naught R1 cube, 4 pi epsilon naught R2 cube, whole thing 1/3. Here also 4 pi epsilon naught R1 cube, 4 pi epsilon naught R2 cube, whole thing 1/3. C1 cube, C2 cube 1/3. Again look in. Here we can write this ratio. If I put this in 1/3, no? 4 pi 3 epsilon naught cube, so I can put them together. Put them together. Whole thing 1/3. This is going to be C1, this is going to be C2. So effective capacitance can be found. Effective capacitance can be found. Right. Two audio systems A and B produce sounds with intensity 90 and 95. If the corresponding intensities are IA and IB, ratio IB over IA is. So delta beta 2 minus beta 1, 10 log IB over IO, 10 log IA over IO. Simplify this. Take 10 out. Log subtraction is division. IB over IA. Here 95 minus 90 is 5 decibels. Here 0.5 log IB over IA. Remove the log here. If you remove the log, IB over IA is going to be 10 to the power 0.5. That is going to be square root. IB over IA is square root 10. Answer is answer number 4. Answer is answer number 4. Question 11. When a ball of mass 0.1 kilogram is thrown vertically upwards in a vacuum, it reaches a maximum height 5 meters. When the ball is thrown upwards with the same velocity in air, it reaches a maximum height 2 meters. Average resistive force. Average resistive force. So in a vacuum, apply. Kinetic energy equals gain in gravitational potential energy. Half mass into velocity squared equals mg, height is 5. 5 cancel off. V squared equal 100. V equals 10 meters per second. When the ball is thrown with the same velocity, this one, maximum height reached in air, object goes up, weight is acting downwards. So impulsive force given. Here air resistance force. Height is 2 meters. Comes to rest. What are they asking? Average resistive force. So work done by external force equals increase in kinetic energy plus work done by resistive forces. There is no external force pushing this up. No external force. No external work done. Increase in kinetic energy will be a loss. Final kinetic energy minus initial kinetic energy. Half mv square. Resistive is work done by weight 1 times 2 plus friction into 2. Take it that side. Half mass 0.1 100 2 times Fr times 2. 5 minus 2 Fr times 2. Friction is 3 over 2, 1.5 Newton. So 1.5 Newtons means answer number 1. Answer number 1. Okay. Next one. Figure A shows two blocks weighing 100 Newtons and 400 Newtons respectively. Figure B shows a situation where heavier block in a system is removed and we pull it down with 400 Newton. The respective accelerations of 100 Newton block in both the situations is, look at the board carefully. Here 100 Newton, here 400 Newton. Heavier will come down, lighter will go up. Simplify this. 400 down, 100 up, 300. Mass is 10 and 40, 50. A. 6 ms minus 2. Here, I am applying 400 means here also 400 Newtons. Apply F equal ma in the upward direction. 400 minus 100 mass into acceleration. 300 equal 100 A. Mass is 10, no? Answer is 30 ms minus 2. So they are especially talking about 100 newtons. No? So here 6 ms minus 2, 30. Correct answer is going to be answer number 5. Correct answer is going to be answer number 5. Right. Two voltmeters A and B having interresistance 1005, 13,000 are connected in series and in parallel with ideal batteries. Which of the following correct indicates the voltage across A and B? So here you have ammeter 1005. Here also you have how much? 13,500. Here 1500 ohm. Battery EMF 10 volts. So what is your reading when it's in series? So you can find the voltage at A, 1500 multiplied by 10 divided by the addition, 15,000. 1 volt. What about the voltage across B? 13,500 times total voltage divided by the addition. 2 zeros, 2 zeros, 3 zeros. 9 volt VV. Series connection 1 and 9. 2 is correct, 5 is correct. What about parallel connection? Parallel connection means voltage same. Parallel connection means voltage same. Correct answer is answer number 2. Correct answer is answer number 2. Right. In the circuit shown, batteries have negligible interresistance VA, VB, VC, VD, respective potentials at ABCD. So what can you say here? There is a current going through this. Here there is a current going through this. Are these currents mixing? No. Because if this current goes here, lesser current will come to the battery. So this current remains here, this current remains here. Apply Kirchhoff. Sum of EMF, sum of potential differences will equal I1 times 12. I1 is 1 ampere. Apply Kirchhoff here. Sum of EMF, sum of potential differences. 6 equal I2 times 12. I2 is 0.5 amperes. Now what? VB minus VD. If I join this and that with the imaginary line, VB minus VD. So you apply the loop B to D. So here it's going through the imaginary loop. Sum of EMF equals sum of potential differences. Inside, do we have a battery here? Yes, minus 6. Voltage is going from D to B, VD minus VB. Simplify. VB minus VD is equal to 6 volt. First one is wrong. VBC. Voltage between B and C. Apply loop carefully. B and C. If you apply here, sum of EMF equals sum of potential differences. Do I have a battery in this loop? No. Loop direction, current direction opposite. 12 times I1. Here nothing. Loop direction, current direction same. 12 times I2. Joining B and C, VB minus VC. Simplified. VB minus VC is 12I minus 12I2. VB minus VC is 6 volt. VAC some EMFs, some potential differences. Well, loop direction, current direction. VA minus VC minus 6 volt. Next, twelve times I1. Twelve times I2. Minus 12 cancel off, minus 6. Correct. Fourth one is correct. Question 50. When a magnet is brought closer to three free rotating discs having the same moment of inertia, same angular velocity, A is found to stop first, followed by B and C, which is true. Remember, if A is stopping first, quick dissipation of heat is taking place. Quick dissipation of heat is taking place means eddy currents are formed. Eddy currents are formed means guaranteed it should be a metallic container. Metallic container. Right. Then B stops. Then B stops. So if there is a laminated disc, eddy currents will not form. Plastic disc, no eddy currents form. So it will keep rotating for a long time. So correct answer is going to be answer number 3. Answer number 3. So metal disc, eddy currents form. Eddy currents form. Loss in energy is high. Then laminated disc. Laminated disc. Less eddy current formation. Less eddy current formation. Plastic dish. No eddy currents form. No eddy currents form. So it will take a longer time to rotate. Here, longer time to rotate. A magnet flux density 1 Tesla between the poles of electronic balance. A rectangular wire loop. So what we can do here is first close this. Measure the current through the circuit. 40-volt battery. Sum of EMF, sum of potential differences. 40 is equal to current times resistance here. I equals 4 amperes. 4 amperes. So we have found the current in the loop. Current in the loop is already found. Now what have you done? If I apply field current force. Field current force. So magnet is pulling the rod downwards. Rod is pulling the magnet in the upward direction. Action, reaction force. Magnet will pull the rod downwards, rod will pull the magnet upwards. So reaction will reduce. F is equal to magnetic field BIL 1 Tesla, current is 4, length is 5 centimeter, convert to meter. 20 10 to the power minus 2 Newton. Simplify this. How much? 0.2 Newton. That's about 20 grams. So the reaction will increase or reduce. Reduce by 20 grams. Why? Magnet is pulling the rod down, rod is pulling the magnet up. Magnet is touching the surface. So magnet is moving up means reaction reduces. So it will decrease by 20 grams. Decrease by 20 grams. Okay. Question number 17. A conducting wire loop bent in the shape of a parallelogram enters a uniform magnetic field as shown. Variation of the induced EMF. Very simple. So as it enters, it will increase like this, then reduce like this. So magnetic field increases, reduces like a triangle. So once it's completely inside, nothing. When it's going outside, induced EMF will be in the opposite direction. Look at this. So right hand rule. Field, motion, current. Or gradually field will increase. The moment it enters like this. Gradually field is increasing. To oppose it, current will travel in the opposite direction. Now when it's completely inside, there is no current passing through. When it's coming outside, little by little field will reduce and increase it. Current will go clockwise. So anti-clockwise, clockwise. What is more suitable? Correct answer is answer number 2. Correct answer is answer number 2. Right there. when the loop enters the magnetic field, to oppose the increase in the field inwards, we place the thumb outwards and there will be an anti-clockwise current. We place the thumb outwards and there will be anti-clockwise current. When the loop is completely inside, with time there is no change in the magnetic flux. Therefore, there is no induced EMF. As it moves out, the field inwards will reduce. We must oppose it. So I'm increasing in inwards and increase the field inwards. This will give us a clockwise current. So anti-clockwise, clockwise current. Right. Temperature on a sunspot is 400 Kelvin. Surrounding solar surface is 600 Kelvin. The ratio of the intensity of the sunspot. Intensity equals rate in which heat is transferred per area, directly proportional to 4th power of absolute temperature. So intensity of the sunspot, that is 4000 to the power 4. Here 6000 to the power 4. Divide one by the other. Intensity of the solar spot, intensity of the solar surface. So 4000 over 2000, 2 over 3, 2 to the power 4, 16, 3 to the power 4, 81. 16 divided by 81, answer is answer number 5. 16 divided by 81, answer is answer number 5. Okay. Question 39. When an atom of radioactive element emits a beta minus particle, beta minus electron, it is transformed into an atom of a different element. A different is formed in this manner because, so what happens? A beta minus particle is emitted how? From the nucleus, a neutron is broken for a proton, electron. Proton remains, electron moves out. So in the nucleus, radioactive elements gain neutrons, wrong. A proton in the nucleus of the radioactive element changes into a proton, wrong. A neutron in the nucleus changes into a proton. A radioactive atom emits one of its electrons from the outer surface. So this one looks correct. A neutron in the nucleus of the radioactive element changes into a proton. Correct? No? Neutron changes to a proton and an electron. Electron is emitted, proton remains. Answer number 4. Question number 20. Which of the following gates shown can be combined to construct a circuit in order to binary output out for input binary dual combination 0, 0, 1, 1 respectively? We are combining. 0, 0 is 0. One is 1. right? Which of the two gates shown can be combined to construct a circuit in order to obtain binary output 1 for input 0 0? These just a simple opposites, no? XNOR gate, I think we can combine R and U, no? R and U are combined, XNOR gate is formed. XNOR gate is formed. Normally, if you take A and B inputs, A exclusive or 0 0 1 0 0 1 1 1. Here you will get 1 1. Here A exclusive or B bar 1 0 0 1. So R and U together. Third one looks good. Third one looks good. Okay, no? Third one looks good. Right. Structured essay. Part of an experiment setup that is used to determine the thermal conductivity of metal is Searle's apparatus as shown. Draw the figure of the apparatus that you need to connect tube R. So to connect here, what do you need? You need what? Constant volume device. It's the overflow. So this is your inlet. This is your outlet. This is the overflow. This should be connected. Constant pressure head device. What additional instruments are essential in order to perform this experiment? So you will need a vernier caliper. You will need water. Stopwatch. So vernier caliper needed. Vernier caliper is needed. So vernier caliper, steam generator, vernier caliper, steam generator, stopwatch. Stopwatch, triple beam balance, triple beam balance, end A of the metal bar is heated using steam. Give two reasons as to why it is sent through P rather than through Q. So why are you sending it through the top? Very simple. If we send through Q, condensation will occur. And stop the flow. Of continuous steam. right? Next is, if we send from P, steam will remain inside the chamber, for a long time. It's easier to maintain the temperature at that end. Okay, no? So if I send through Q, if I send through the bottom, what will happen? Condensation will occur and block the flow of steam. So I can't maintain this at 100. But if I send steam from top, steam will remain in this chamber for a long time. So this can be maintained at 100 degrees Celsius. It can be maintained at 100 degrees Celsius. Right. Okay. How do you observe the system has reached steady state? So I can observe thermometers T1 and T2. They become stable. So thermometers T1 and T2, or the thermometer readings, do not change. The thermometer readings remain constant. How do you achieve a good thermal contact between thermometers T1 and T2? Insert some mercury. Insert some mercury. You are provided with the following data set. Calculate the thermal conductivity of metal. So, rate of heat conducted equals rate water absorbs heat. So here K times A delta theta over delta L. Mass of water times specific heat capacity of water. Change in temperature of water. Change in temperature of water 37 minus 28. Thermal conductivity we don't know. For sectional area 1.2 10 to the power minus 3. Change in temperature 75 minus 61 divided by distance between them 0.08. Mass of water 0.4, 3 minutes 180 seconds. 4200. Change in temperature there 9. Simplify this, find K. If you multiply this, easily you can find the value of K. 400 watt per meter per Kelvin. Space X is filled with good thermal insulators such as polystyrene. Produce heat loss. Thermal conductivity of air is 0.025 and polystyrene is 0.08. So air is a better conductor. Or in other words, air is a better insulator because conductivity is less, which implies that air is a good thermal insulator. Explain why it is still better to use polystyrene than air. Very simple. In air may be a very good thermal insulator, but there will be more loss of heat due to convection. Due to convection. So why don't I use this? Because I don't use it. If I use it, there will be more loss of heat due to what? Convection taking place. So remember, here in this particular problem, we can't use air or any liquid. Why? There is more heat loss due to what? Convection taking place. Right. Look at this carefully. Two monochromatic layers of light angles, theta 1 larger than theta 2. Theta 2 is smaller than critical angle, where theta c is the critical angle, are falling on air. Complete the path of the rays. Complete the path of the rays. Theta 2 is smaller than the critical angle. If theta 2 is smaller than the critical angle, light rays will refract away. Theta 1 is larger than theta 2. Larger angle, greater deviation taking place. Larger angle, greater deviation taking place. Here theta 1 is larger than theta c. Small correction. Others both look the same. No? Theta 1 is larger than theta c means here total internal reflection takes place. Here refraction will occur. Correct this, sir. Theta c. You are asked to determine the critical angle of glass by method of total internal reflection. Prism is placed on a white sheet of paper in such a way that vertical pin M is in contact with the face AB, AC. This is what we do. We make sure that what? Light rays directly travel. No refraction takes place. Here, no refraction takes place. In this experiment, the pin M has to be placed in contact with the face. State the reason. No refraction must occur. No refraction must occur from surface AC. Light rays must directly travel in. Light rays must directly travel in. Directly travel in. When you move your eye from B to C while looking through the face EC, what change in the image of the pin M do you expect to observe? So what change? When you move your eye from B to C at one instant, the image of M is just about to disappear. The image of M is just about to disappear. The image of M is just about to disappear. Right. How do you detect the path of the relevant emergent ray? Experimentally using two other pins. The location of the pins are marked as X and Y in figure 2. So what do you do? So here when the image is just about to disappear, place two pins X and Y in line with the image. When the image is just about to disappear, when the image of M is just about to disappear, just about to disappear, Place two pins X and Y in line with the image of M. Write down the remaining steps in order to construct the ray diagram. Use figure 2 to illustrate the steps necessary in your diagram. So what do you normally do? These are the constructions. Writing words. From M, draw perpendicular to this point. Extend it until MD equals D. Join XY with a straight line. Join XY with a straight line. Draw normal. Join EF with a straight line. Where it cuts here is G. Join MG. Measure angle MGF. Measure angle MGF. It's going to be 2 times C. Right. What measurement do you take from the ray diagram? And also clearly indicate it on the ray diagram. So we will measure this angle here theta. Measure the angle theta. You are asked to modify and repeat this experiment to find the critical angle of glass water interface by forming a thin water layer on the surface as shown. Right. Where would you new location of the images be? Now what will happen? Now water is there, glass, air, big difference, glass, water, small difference, lesser diffraction takes place. So this will be closer X dash, Y dash. Closer image will form. They are asking where will the location of the image of pin name? Image of pin name, no change. That of course no change. Draw the new emergent ray relative to X and Y. Label X dash, Y dash. I think here I have drawn. So here light ray. Here light ray. There you go. So if I draw it a bit more clearly, image will form at the same location. No? Image just about to disappear. X dash, Y dash. There you go. There you go. Critical angles determined in part B and C above are C1 and C2. Find expression for relative refractive index of water in terms of C1 and C2. So here this diagram here. Here refractive index of glass sin C equals Na sin 90. Refractive index of glass sin C dash NW sin 90. If I divide it, sin C over sin C dash Na over NW. Refractive index of water is sin C dash over sin C. I think they are given C1 and C2. C1 and C2. Huh? Right. So if I write like this, you can obtain a relationship. Right. What measurement would you take from the ray diagram? Now, these are earlier ones which we did. Right. Essay question. Poiseuille's equation can be written as pi delta P R cube 8 eta L. Identify each symbol of the equation. So Q is equal to volume flow rate, delta P over L, pressure gradient, R, radius of the tube, eta, coefficient of viscosity. Show that the above equation is dimensionally correct. So you can easily show it here. Consider left hand side dimensions. Volume flow rate L cube T minus 1. Consider right hand side dimensions. Pi delta P R to the power 4 8 eta L. Dimensionless ml minus 1 T minus 2 L to the power 4 ml minus 1 T minus 1 L. LL cancel off, mm cancel off. L cube T minus 1. Left hand side dimensions equals right hand side dimension. Crude oil of viscosity 0.9 has to be delivered from harbor to refinery using a straight horizontal tube of internal radius 20, length 1, average speed. Calculate the pressure difference maintained. Q is equal to pi 8 eta L R to the power 4 delta P. So volume flow rate, area into velocity. Volume flow rate is that. Pi R to the power 4 delta P 8 eta L. pi r squared v, pi r to the power 4, delta p 8 eta l, pi cancel off r square. V is equal to r squared delta p 8 eta l. Delta p is equal to 8 eta l v over r squared. Eta value 0.9. Length 1 kilometer. Velocity average 1. Radius 0.2 square. Simplified. 0.04. 800 divided by 4, 200. 180 10 to the power 3. 1.8 10 to the power 5 Pascal. So 1.8 10 to the power 5 Pascal. Right. Easily found. What's the minimum power needed to deliver oil through the pump at the given rate? Power is equal to pressure difference into volume flow rate. Volume flow rate. Pressure difference 1.8 10 to the power 5. What's the volume flow rate? Volume flow rate, area into velocity, pi r squared v. 1.8 10 to the power 5, pi is 3, radius is 0.2 squared, average velocity is given, no? Average velocity is given 1. 0.04 times 3. 4 times 3, 12. 1.8 times 12. Minus 1 squared minus 2. 10 to the power 3. 96. 9. 21. 10 to the power 3. 2.16. 10 to the power 4 watt. 2.16. 10 to the power 4 watt. At what radial distance the speed has to be maximum? So if you take a tube, if I draw the velocity profile, at the center only it's maximum. Then it starts reducing. Right. So minimum velocity is 0, no slip condition. What's the value of the minimum speed? 0 meters per second. Why? No slip condition. Liquid touching the boundary is going to be 0. So here R equals radius radius 20 centimeter. Radius 0 meter only V max. Right. Internal radius of a metal tube is decreased by 10% due to deposits. What percentage the pressure difference across should be increased in order to deliver the same rate as above? Volume flow rate pi eta L r to the power 4 delta P. What percentage the pressure difference across the thing should be increased? Same rate, area into velocity, pi r to the power 4, 8 eta L, delta P. Simplified. pi r squared v, pi r to the power 4 8 eta L delta P. Pi r squared cancel off. Pressure difference is 8 eta L V r squared. What's happening is internal radius is decreased by 10%. What is the percentage that the pressure should be increased in order to deliver the same rate? So looking at this same rate, length is same, pressure difference. So we'll write like this. Pressure difference inversely proportional to the fourth power. Pressure difference inversely proportional to fourth power. New pressure difference 0.9 r to the power 4. Delta P1 over delta P 0.9 to the power 4. Delta P over delta P 9 divided by 10 to the power 4, that's 10 divided by 9 to the power 4. That's going to be 1.11 to the power 4. Right. Percentage increase in pressure. Delta P1 minus delta P divided by delta P into 100. 1.11 to the power 4 minus 1 into 100. 1.11 to the power 4 minus 1 into 100. 61.8. It's a simple problem. 61.8. Two smaller tubes having similar radial lengths are now fitted to the ends of the metal tube mentioned above. Oil is delivered to two other refineries. So from here it's coming, we connect it to two other refineries. Length of the small tube is also 1 kilometer. Pressure difference are all equal. Find the radius of the smaller tube. Similar radius and radii. Here radius 0.2. So volume flow rate 1 plus volume flow rate 2. Q dot 1, Q dot 2. Here Q dot. Simplify this. Pi 8 eta L 0.2 to the power 4. Pressure difference delta P. Q dot 1 pi 8 eta L 1 kilometer. This is how much? 1 kilometer. R1 to the power 4 delta P plus pi over 8 eta L R1 to the power 4 delta P. All these cancel off. Pi delta P, pi delta P, pi delta P cancel off. 0.2 to the power 4, 2 times R1 to the power 4. R1 cube root. 0.2 divided by 2 over quarter. .68 10 to the power minus 1 meters. Done. Radius calculated. Right. So the first essay was based on Poiseuille's equation. Poiseuille's equation. Poiseuille's equation. Here average velocity is given, so pi r squared times v. You can find the connection. Maximum velocity will always occur at the center on the main axis. At the boundaries, velocity is minimum. Apply equations, you can find the pressure drop. Whatever comes here will divide and travel. Simplify, you get the answer. Right. If the mass and radius of the earth are m and r respectively, write an expression for the gravitational potential at point P, which is at a distance h from the center of the earth. Radius r, mass m. Potential here is minus gm over h. Potential at A. Right now. Suppose small object simple m is projected vertically upwards from the point with a velocity v1. Write an expression for the total mechanical energy starting there. So here somebody projects it with a velocity v1. What's your mechanical energy there? Kinetic plus potential. Kinetic energy plus gravitational potential energy. Total energy at A. Half mv squared minus g capital M simple m over h. Right. Obtain expression for the maximum height object travels in terms of this. So total energy at A equals total energy at max height. Total energy at A is half m v1 squared minus g capital M simple m h. Once it reaches there, no kinetic energy, minus capital M gm divided by h max. Obtain expression for the maximum height. Cross multiply m v1 squared simple h 2 capital G capital M simple M over 2h minus t capital M simple M h max. Send the minus here. 2g capital M simple M minus mv squared h over 2h g capital M simple M h max. Turn upside down, h max is equal to 2g capital M simple M h divided by 2g capital M simple M minus mv1 squared h. There you go. All the simple masses you can remove. Simple m's you can remove. And you can rewrite this. H max equal 2g capital M capital H. 2g capital M minus V1 squared simple H. Find the expression for the escape velocity in this situation. Escape velocity means H max is infinity. Therefore, 2gm minus V1 squared H is equal to 0. So here 2gm escape velocity squared H 0. Escape velocity is 2gm H over square root. 2gm H over square root. If u0 is the speed to keep the object in circular orbit, show that escape velocity is root 2 v0. So if you are keeping the object in circular orbit, at a height h, centripetal force equals mass into centripetal acceleration. Capital G, capital M, simple M over h squared. M v squared over h. V is equal to gm over h square. Escape velocity is root 2 gm over h square root. Root 2 gm over h. Root 2 v0. If m is 6 10 to the power 24, r is given, calculate the escape velocity at the surface of the earth. 2 gm radius of the earth. 2 6 10 to the power minus 11, mass 6 10 to the power 24, radius 6400, 10 to the power 3 square root. Simplify this. 12 over 64 12 over 64 10 to the power 8. 12 over 1.05 10 to the power 4 meters per second. Right. Mean temperature of the surface of the earth is 280. Calculate the mean square speed of H2 and O2 molecules at the same temperature. So 3 kT over simple M. Hydrogen. Oxygen. 3 kT over M of O2. Here. You can get two different speeds. hydrogen 1960 meter per second. Oxygen 490 meters per second. For a given temperature, gas must have a range of speeds. To retain a given gas atmosphere, escape velocity should be smaller than 6 VRMS. So for hydrogen, 6 times VRMS. Six times VRMS. $1,960. $11,760. This is greater than escape velocity. Therefore, hydrogen gases escape Earth. For O2, 6 times VRMS, 16, 490. This is going to be smaller than the escape velocity. Therefore, O2 will remain. So the conditions are there, no? For this condition, we are finding. Okay. For this condition, we are finding. Right. So it's a long paper, 2 structured, 2 essay, and 20 MCQs. So I hope it was helpful. Make sure now the next paper also will be having the same load of content. So make sure you study it and carefully do it. That's all again with week 10, day 3.